Alright, 7.8, inverse functions and relations. Okay, so here's the deal. An inverse is simply just switching, just writing it over here because you're going to want to memorize this, the x and the y. That's really all there is to it. Even with relations, which is what we're about to do, and with functions, which we're going to do in a second. So, first, let's take a look at these guys. We're going to just plot all these points. Let's do these ones in blue. So we're going to go to 2, 1. There's a point. 5, 1. There's a point. 2, negative 4. There's a point. Okay. Now the inverse of these is just going to be us literally switching the x and the y. So it's going to be 1, 2, 1, 5, and negative 4, 2. That's it. So 1, 2 goes here. 1, 5 would go here. And negative 4, 2 would go here. And if you wanted to look at this as like a triangle, these 3 points, you see something kind of neat going on here. Oops, I want to do that in blue. Because inverses are always going to kind of just flip across this line, y equals x. And that's what I'm talking about over here. Inverses flipped around the line, y equals x. Well, look, it kind of just reflected across that line. And there we got the inverse. Okay. So that's how you define an inverse relation. What about an inverse function? We have a little property of an inverse function. That is, if you put in A to the first function and it kicks out B, when you put B into the inverse, it should kick out A. But let's talk about how to find the inverse of this function. We'll graph both of them in a second, but let's just talk about this. This is f of x equals x plus 6, which is like saying y equals x plus 6 over 2. If we wanted to find the inverse, though, we would just switch the x and the y. So it becomes y plus 6 over 2 equals x. And now we need to get the y all by itself because that's proper form, right? Let's get the y all by itself. So we're going to multiply both sides by 2. So we get 2x equals y plus 6. The next step is to subtract 6 from both sides. And so finally we get, we put the y on the left side, equals 2x minus 6. Okay, the only thing is, we don't leave it as a y because it didn't start as a y. So we're going to leave it as f negative 1 of x. That means inverse 2x minus 6. Alright, there's the inverse. There's the original. Now let's just graph them both. I'm going to graph this one in blue and the inverse in black. So, x plus 6 over 2. Well, this might be a little bit easier for you guys if you just saw this as 1/2 x plus 3, because that's really what this is. If I was to divide x by 2, it would be 1/2 x. 6 divided by 2 is 3. So this is really just like y equals 1/2 x plus 3, which we should know how to graph. So, go over here, go up 3, then go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Okay, there's the line x plus 6 over 2, or 1/2 x plus 3. Now let's do this one, 2x minus 6. Okay, well we got to go down 6, and then our slope is 2, so we're going to go up 2 over 1. Instead of up 1 over 2, now it's up 2 over 1. Okay, and you should be able to see that these lines are reflected across, again, this line, y equals x. And look, even where they meet up is right on that line, y equals x. Should be right here. My drawing's a little bit off, but it should be right there on that point. And so there, we have found the inverse, we've graphed the original and the inverse, and we're done. Let's go on to the next page. Oh wait, let's do this real quick. I do want to show you something. If you were to take a number, let's say like 5. Actually, let's do a number that's a little bit easier. Let's do an even number. So let's say we were to take 4. 4 plus 6 is 10. 10 divided by 2 is 5. Okay. Remember, we started with 4, we ended with 5. Now, if I take that 5 that I ended with and plug it into here, 2 times 5 is 10. 10 minus 6 is 4. We end up with what we started with here. And so that should always happen with inverse functions. What you plug into one, if you get something out and you plug it into the inverse, it should give you back what you started with. Just a little way for you to check and see if your inverse is correct. Let's take a look at these guys. Two functions are inverses if and only if you can plug them into each other. So if they're composition functions like we did in 7.7, and what you get back out is an x. So let's test this. Let's do f of g of x, and then we'll do g of f of x and see what we get back. So these are supposed to be inverses, but let's check. So to find f of g of x, we're going to take g of x, which is this thing, this function, and we're going to plug it into this function where the x is. So that means that f dot g of x would equal 5, but instead of an x, I'm going to put 1/5 x minus 2 plus 10. So see what happens here? I took this whole thing and I just plugged it in for an x right there. Okay, so let's play with this, see what happens. 5 times 1/5, well that's just x, and 5 times negative 2 is negative 10, and I have a plus 10 out here, so then I have a negative 10 and a plus 10, so this just equals x. Look at that. That's what it should do. Now let's do the opposite. Now let's take this guy and plug it in for an x there. So I have 1/5. Actually, remember this would be g of f of x, which means I'm going to take function of f and plug it into g. So 1/5, and instead of an x, I'm just going to leave parentheses, minus 2. And I'm going to take this guy and plug it in. So I'm going to put in a 5x plus 10. Okay, well let's see what happens here. 1/5 times 5 is just 1, so I just have an x. 1/5 times 10 is 2. Bring down this minus 2, x plus 2. Negative 2 just becomes 0, and so I'm left with just x. That is how you test to see if two things are inverses. You plug them into each other, and you should just get back an x. And I did. Both times I just got back x. All right, that's it for 7.8.